Alright everyone, today we're going to talk about relationships. Math relationships. Specifically angle relationships in circles. So, let's get going. Definition. A circumscribed angle is an angle whose sides are tangent to a circle. So our red angle down there is our circumscribed angle. So it's from an external point on the circle, and the sides of the angle are tangents. Here's the scary part of this lesson. This is our only definition. So, I'm not sure if that's good or bad for the future. Tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the intercepted arc. So, what we have is we have a tangent here to the circle, and we know it's tangent because it's indicated that it makes a right angle with the radius. And then we have this chord. And what you get is an angle. Angle X. And we also get this intercepted arc y degrees. So X equals 1/2 y. It's kind of like it's an inscribed angle, but it's not. So, but we have the same formula as an inscribed angle. So we get this arc, and the measure of that angle formed is 1/2 the arc. So think of it as an inscribed angle's formula, but it's a bit different. Angles inside the circle theorem. This is a long one. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Remember to breathe. So, it's a lot of words that mean this. We have two chords here in the circle. It doesn't matter where they are, it's just that they are intersecting. So our two chords intersect, and we get two angles. We're just focused on angle X here. Because we have two angles, we also have two arcs, right here and right here. So, if we want to find the measure of X, X equals 1/2 times Y plus Z. So if we want to find the measure of that angle in there, we have to add the two arcs on the outside and multiply them by 1/2. So take half of them. So that's all those words into a simple little formula. Angle outside the circle theorem. So this is an angle that lies outside our circle. It says if a tangent and a secant, two tangents, or two secants, so we have three cases. Tangent, secant, two tangents, two secants. Intersect outside a circle. So the point where they intersect is outside of our circle. Then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So again, we get two arcs here, and we have one angle we're trying to find. So we're trying to find this angle out here, and we have two arcs that are intercepted. We have this little arc and this big arc. So the measure of our outside angle is 1/2 times the big arc minus the little arc. So 1/2 times the big arc minus the little arc. Last theorem, the circumscribed angle theorem. The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle. So, we're looking for the measure of angle X out here. What we're going to do is we are going to take the measure of that central angle that goes with our circumscribed angle. Remember, a circumscribed angle is formed when we have two tangents, so these are tangent. So we take 180 minus this angle right here, and that tells us our outside angle. So, there are all of our relationships with angles.